To begin, the ball is at rest in the net of the player's stick. Because of inertia, the ball remains at rest inside of the net until a force of the player throwing the ball acts on it. Then, because of Newton's first law of motion, that ball that was in motion remains in motion and keeps rolling past Lindley with a constant speed in a straight line path. This speed can be determined by dividing the distance traveled by the time elapsed. Then, Lindley throws the ball back to Aaron, and when he catches it, like that, also because of Newton's first law of motion, that ball stopped its motion when his catching force acted on it and the motion ceased. You can calculate two different versions of Aaron's running speed. The first speed is instantaneous speed, which is his speed at any given moment. For example, if we took his speed at the exact moment that he crossed the yellow arrow on the track, then that would be his instantaneous speed. We can also find his average speed by dividing the total distance that he ran on the track by the time it took him to run it. His acceleration can be found by dividing his change in velocity over the distance by the time elapsed. Because of Newton's second law of motion, when Lindley throws Aaron the ball accelerates in the same direction of her throwing force. You can measure this force with the equation F equals ma by multiplying the mass of the ball by acceleration due to gravity. The greater the mass of the object being thrown, the greater the force needed to accelerate. When Lindley and Aaron run into each other, their acceleration and motion stop. This is because their forces were balanced. A projectile motion has horizontal and vertical components. When thrown in the shape of a parabola, the vertical speed of the ball is 0 at the peak of the parabola. However, the horizontal velocity is constant throughout when ignoring air resistance. As the ball rises, vertical velocity slows down, and as it falls, the velocity speeds up. The greater the distance of the throw, the greater the degree of the throw, the shorter distance that the ball is projected. Newton's third law of motion states that forces act in pairs, and for every force there is an equal and opposite force. These two forces always act on different objects. For example, as Aaron runs, he pushes down on the ground with his feet, and the ground simultaneously pushes back up on him. Frictional force is equal to the force required to slide an object on a surface with constant speed. This is shown when Lindley pushes the ball across the track. Mu is the force of friction divided by the normal force. Normal force is the upward force, or the force that is equal and opposite to gravity.
Love you, Mr. Pate.
There are two different kinds of energy, potential energy and kinetic energy. Kinetic energy is energy in motion, and elastic potential energy is energy of a position above Earth. This is shown by Aaron's shot. Before he jumps, all of his energy is kinetic energy while he's running. When he jumps, this energy turns to elastic potential energy. And then when he's at his peak in the air, the energy is gravitational potential energy. At all times, the total energy, regardless of type, remains constant. Elastic potential energy is found by 1/2 times the spring constant times the compression squared. Gravitational potential energy is mass times gravity times height, and kinetic energy is found by 1/2 times mass times velocity squared.
Lindley is in her ready position, which is showing elastic potential energy, like a spring. Once Lindley launches off the ground, now she is performing kinetic energy. Whenever she is in the air at her peak, this is a form of gravitational potential energy. As she's in the air, she is performing hang time. The end. Thank you.